So the next session is, I guess, a kind of therapy for people that are used to living in monolithic hell. There's an escape, and these gentlemen are going to tell you how to get out of it. There's a couch, so just in case it doesn't help. No, we have our friends from KPS, and if you've paid attention, you might have noticed their logo in the partners section. So it's not a complete coincidence that they're working with this stuff, but they're doing some pretty exciting things. So please give a warm welcome to Tobias and Oliver.
Yeah, thank you very much. Okay, now I can hear myself. Thank you. Thanks for having us here on this stage and within these 2 days in Amsterdam. I'm Oliver, and this is my colleague Tobias. I think first of all, and beside of introducing ourselves to you, Tobias, have to explain a little bit the title of our presentation. As we heard before, it might be a therapy session, but it's way more. For sure, highly paid marketeers worked for hours, days, and over the weekends to come to this perfect title. But just kidding. The thing is, we are standing here as a representative of the company KPS, which is a leading IT service provider. But on the other hand, and this is really important, and also what we learned in the morning, we are standing for different roles in projects. So we have architecture and development on the one hand, and project management, business consulting, and requirements engineering on the other hand, or the other side. And we have worked together many times, and when we are talking about a health situation, we know exactly what we are talking about, right? But it's more than just between roles and persons. But in the morning we had this question about, please raise your hand when you are not a developer. And I had to blame myself, yeah. And you can punch me afterwards. But the thing is, that is also to be considered between roles, how it works together and how can we do that end to end. Therefore, in this little presentation, we want to give you a short snapshot of some of our projects dealing with this hell, with monolithic hell, but also with all these influencing factors we have and we have to achieve. So let's start with these common situations in between stressful general conditions, project challenges, and architecture approaches. From a poor, let's start this here. It's eaten at time. Oh. From a poor IT perspective, we know exactly where the challenges are. Yeah, the challenges. But especially from this more technology-driven or bottom-up view, we have to focus more on the influencing factors. The world in which we are living is the so-called VUCA world. So we have volatility, complexity, uncertainty, and ambiguity. And over the last few years, this had never been more evident than it is now. We see crisis coming up. Right? Heavy pollution and other dramatic elements. It's an IT conference, I know. But all these factors have large impact, more and more large impact on companies, their business development, and therefore also for the projects. And here, the so-called economy of speed becomes a real key success factor, where you must be smarter, quicker, and more reliable when you are working. And this brings up the need for scaling up the speed of development itself. But what is the reality when lifting the curtain? We are facing a limiting situation with the systems or technologies which are already in place. And on the other hand, from the top, we have this high expectation from customers, and they are targeting us. Yeah? So the thing is to bring things to success. The challenge is to focus on this end customer and their specific needs. And by this, we have a shift from applications to services and from projects to products. That is really important. And business processes we see when we enter the companies are tightly coupled to that. And that is the challenge. Architecture and development must strongly respect that. And things like sustainability, reuse or composability must fit to that. That is really important. And with this, while also more and more independent or self-organizing teams come up and agnostic architecture and development. But what is it now the specific problem for an IT service provider and what have monolithic structures to deal with it. The thing is, when we are asked to bring in a solution for a given problem, we have to deal with it. And it even goes further. So KPS is working with more than 3,000 consultants all over Europe in several offices and over various projects. And the customers are most of the time already the industrial leader of their area or with the challenge to become one. And KPS was founded in 2000. We have handled hundreds of projects until now. Therefore, we just had a slight selection of them dealing especially with the structures which mentioned here and also with the technology we are talking about, especially in these days. But also we have this brightly mix between consulting, projects and architectural approaches, and also innovation initiatives. They are all in some way related. When entering a new project or starting it, it's in some way related to the situation when I enter the room of my little son. Yeah? He already crafted out a lot, but now he wants to change something. Yeah? Or something is not working, he wants to adapt elements. And the slightly difference between this situation and a professional context is that we are asked to give a solution for a given problem. We have to shortly or immediately ensure profitability. That is the thing, and we do not that just for fun. That is the topic for a service provider in this world. And there are several other things that we mentioned that comes from the simple fact that many large companies of today, and therefore actual or potential customers of KPS, were not growing to that size they have today from a digital market or with a digital product. Most of them comes from an economy of scale situation. And now they want to adapt, they want to change their business and they want to change their way of doing projects. And here we find these given structures dealing with also monolithic structures and systems. And to be honest, also software that has been established on the market for some years and we use for consulting shows this structure. Yeah? So no judging. Monolithic structures are not bad at all. Look at this pyramid here. It's magnificent, outstanding, beautiful, and the structure is clearly to each and everybody who sees it. That is not the thing. But such a structure, the monolithic structure, is a dinosaur in terms of speed. Yeah? So just think about when you come to software development, think about compilation time, build time, startup times, and so on. And the effort it takes to test such a solution or interact with other systems. And this is all commercial impact. And we have not spoken about license costs for now, and we will not do that. Yeah? But this is the thing. And the service provider comes into the game rather late, when many business decisions have already been made. And then we have to deal with it. And then the customer asks for changes or complements. Yeah? With monolithic structures, you have to build with the given structure and with the technology which is in place, and this limits you in some ways. The technology limits you in the way of working. And application often, when you change these applications, this often involves changing many independent elements. Just think about the pyramid again. When the pharaoh now is asking for building a new death chamber in that, how many stones you have to move or change to do that? And they are not directly related to the structure you want to build, but you have to move them. That is what we see often in projects. And then the customer gets unhappy. And this situation is not only shown to service provider, it's also an internal thing that causes frustration. And when there is frustration, internal or on a given market, there are not only problems. We want to not only show problems or give problems. There are chances. There are chances when you have a solution for that. And the chances which are given are also in the race of smaller businesses, where speed onto the market is a key success factor. When we are now in consulting and sales, it's for sure not needed to build the full pyramid at the start of your given project. you can start smaller. But now we want to start with our journey, and therefore I will now hand over to Tobias. And for now we can state that our customer's pain is our pain, and that hurts.
So, welcome to hell. So, KPS as a certain service provider has a certain environment, and that is defined by the customers. So we cannot act freely. The later we join the project, the more things are already set in stone, decided, predefined, and that's what we have to live with. I joined KPS 5 years ago, and to be honest with you, I almost left in the first 2 weeks because it was so bad. I just graduated back then, did my bachelor's degree. I worked for a small company in Munich as a side job, but the conditions are quite different there than when you join an IT service provider. Still, I had to make a decision, and it was a tough one. Either I leave or I try to change things for the better. And that is what I tried to do over the past few years. So this perceived hell was also part of my personal journey the whole time, and each circle of hell, so each project, contains a new form of punishment, but we also learn from it. So this hell opened up in the tension between projects, innovations, and proofs of concepts. So let's start with the first one. It's a European leading shoe retailer with a green logo, and they do 5.3 billion euro turnover in 2021. So it's a quite large company. And until then, the projects we do in our office in Dortmund are mostly SAP Commerce projects. So this is a monolithic shop software. It has many layers, it has any modules, and all the craft you can have in there. And it certainly has had that. But we thought, hey, can we do this a bit better? Our client, they wanted to have a new checkout process. And we said, yeah, let's not do this in this monolith. Let's have instead a REST API and an Angular front end. And in between that, we had an open API contract, which back then was called Swagger. And likewise, and this is the most interesting part about this, we had two teams. We had a front-end team and a back-end team. And we made some really interesting observations here. First, we had Conway's law. So basically, the architecture follows the communication structure of the teams. The back-end team and the front-end team, they mostly talked about, hey, can you add a field here? Can you add another call there? And they were pretty fast with developing new functionality because they just used this contract to generate their calls or some stubs if their code wasn't ready. And likewise, in the backend, we could provide API endpoints with mock data for stuff that wasn't implemented yet. So these teams could move quite independently from each other. And I think that is a valuable learning, that you need some kind of socio-technology here. And that this is also what came with the rest of our journey too. Yeah. So the front-end team was able to move really fast, and the checkout process was actually much faster than the front end. And as for bonus points, we wrote a custom DSL that allowed us to drive this API without the front end, because the front end is just a detail. It's an implementation detail. We don't care in the back end about the front end. So we wrote a custom DSL to drive our checkout process in a domain-driven way, and that was really interesting. We said, okay, we have a user that is called Andy Cancels, for instance, and Andy puts something into the cart, and then he goes to the checkout, and and we could test all the cases in a way that QA could understand. It was really lovely. So let's move on to our next circle of hell. It's a European leading electronics retailer in B2B, and they have an office close to Dortmund. And we came in there quite early, so we did a lot of workshops with them. They had lots of systems and even more interfaces. And this is already 4 years ago. So as far as I recall, their architecture looked like this. They had a custom written ERP and shop system, so both custom written, and they wanted to replace it with SAP products, so SAP ERP and SAP Commerce. And they had all these other systems around that, and what they did is, well, they integrated everything with the centerpiece. So you get a lot of, strong coupling, and it's maybe not so fault tolerant. You can do it, but it's probably not the best idea. And I teamed up with my colleague, who is a senior architect. His name is called Eric. He's a really great guy. And we really learned a lot from each other. And we thought about this. If we just put the shop in the middle, because the shop was back then the center of our world at KPS, then there is no added value into this. So we need to come up with a different idea. And we did some smaller prototypes and proof of concepts in between. So we said, yeah, well, what is the problem here? We have a front end over here. And over there, we have some existing systems, like a product information management. And it has a model of a product. It has an article number and an image. We have an SAP Commerce, which is a shop software, and has maybe a product, and in this system, the product has an article number and a description. And we have ERP, which stands for Enterprise Resource Planning, and there the product has an article number, a category, and again a description. Why not? So there is this strong coupling that you usually do between these systems. You just integrate them with ready-made connectors, but we didn't want to do that. We asked ourselves, how can the data flow from one system to another? And we said, yeah, let's have some kind of, we called it business services, and have some interfaces for connecting into these existing systems. And then we said, well, we need kind of a brain, yeah? So something that coordinates the data flow between the systems and also towards our front end. And that is what we did. So we did some process orchestration in there as a concept. And also this client, they had something domain specific like a metal fee. We were like, what the hell is a metal fee? And it is if you have a lot of copper wire, and there's a lot of copper in there, so you have to pay an extra fee if the market price go up or down. So this is what we did. So there is an abstraction between what does a product mean for the client, for the customer, and what does a product mean in the surrounding system. And also, if you look closely, we pushed the other systems to the outside. They are only infrastructure to this service. So how does this actually work? So from the front end, we need something that is like that requests the product data and that builds the product data. So we need a full product with an article number, an image, and a category and a description. And from there, we said, yeah, well, each system has a slice of data, and we have an interface for that. So here's some data, here's some more data, and if we condense that, we get the full product view. So that is how we reinvented GraphQL in 2018. But we learned a lot from it. So the next thing that we did is something called product information exchange. It was a proof of concept, but it had some interesting parts to it. The challenge here was quite the inverse. So we have a lot of, this client has a lot of independent specialist retailers, and the client is a specialist retailer association. So you have lots of independent retailers, and they unite together to buy their goods at a better market price together. And for that, this customer, they had a master catalog, and then we had this product information exchange, and each of the retailers would get her slice of the catalog. And back then, I was talking to my colleague, and I said, let's use this new shiny Axon framework, but instead, we somehow decided to go with Kafka. So we learned it the hard way. We have some categories, some products, and some stocks exported from an ERP system and uploaded into an importer service. And this service converted it into Kafka messages. And we had, for instance, a search service and a persistence service. So search service to search stuff, and persistence service to aggregate the events to build up these article data that are required for export. We have some kind of request response communication here. We have something that transforms the messages to the output format, and then with the exporter you can request your export. So the thing is, this worked quite well, and we spent about 80% of the time at the whiteboard designing, discussing which message has to go where do I get a reply from. We built a domain-oriented model. We even had this kind of aggregate, but it was, even if it was a small project, it was a huge complexity to it. So let's take a little bit closer look at two of the patterns here. The first is the message and response routing. Kafka is a really dumb message bus. It doesn't care about what's in the body of your message or in the header of your message. So if you want to send a message to topic A, and you set a header reply, I expect a response from somewhere on topic B, then the receiving end has to know how to interpret this header. You have to basically build this into your framework. It's not given to you by Kafka for free. While in Axon framework, for instance, you just send an event or a command or a query, and the rest just happens. And the next thing is, we did all this aggregate lifecycle handling ourselves. And well, you can do it. We saw it in the previous talk also, but it doesn't scale so well in our opinion, so from our experience. Still, what did we learn from this project? You can do it in Kafka, but probably you're better off with Axon framework. If we had some bugs in there that, thanks to the persistence in these topics, in these persistent queues, were quite easy to fix. If you had an exception, you just fixed the issue and it would continue as if nothing happened. And I think the same concept goes with the dead letter event store. So yeah, it was a nice lesson, I think. Why not use Kafka? Well, now you know. So the next one is a leading B2X retailer from the Nordics. And I don't know if you know MediaMarkt. It's also electronic retailers. So this customer is quite similar. It has a turnover of 4.8 billion euros in 2021. And there I came into this project a bit later. but let's have a look how this has been done. So we have a front end again. We have Apollo GraphQL as a kind of backend for the front end. And then there were the backend services. So Apollo did some REST calls. There's some HTTP call to Apollo. There are REST calls to the services. And these did more calls to more backend services. But let's have a closer look how reliable this is. So let's say the chance of success for each call is 95%. Then you whip up your calculator and you do 95% to the power of 6. That is about 73%. So if you don't put anything in between, 1/4 of your calls might actually fail statistically. And that is similar with the performance. So if this call takes 150 milliseconds, this call and this call also, but this call alone takes 1,000 milliseconds. And then you have another 2 calls that also take 150 milliseconds. Let's be very nice here and say you can run all these calls in parallel. Then you have to go the lower path, so 150 plus 1,000 plus 150, and you get a response time of 1,300 milliseconds. So this is how long the customer has to wait in the worst case. And customers, they want modern UX. They are not very patient. So we have some strong coupling here by calling. If I call my colleague Oliver via the phone and he doesn't reply for a long time, that is what you are seeing here. So what we did is to introduce some caching, but then you need to come up with a really good and strong caching concept. You need to know when to invalidate, where to invalidate, and how to invalidate. We have the performance and the reliability problems, and also it's a bit hard to test, to be honest. So that, I think, this is why REST should only be your last resort. It's the least common denominator if you don't have anything else available. So the last one is a real quick one. It's a leading European online pharmacy. And there we have a front end, we have a back end for the front end, we have some simple services, we have some larger integration services for integrating with existing monoliths. And then we have some more complicated services like this user profile data service, which is backed by SQL Server. And in between we have an open API contract again. And then this project has been running for 4 years now and is still in production. And 2 years ago, we introduced Axon Framework in there and use Microsoft SQL Server as an event source. So what we did is we migrated over 10 services from the left side from a regular REST service to this Axon framework-based services. And so there is a migration path here. And likewise, what if the performance is not enough anymore of this Microsoft SQL Server? Well, then we already prepared the migration path to Axon Server, and we are still good. We always have the option of doing this. So that was our travel through the circles of hell. But now it wouldn't be good if we didn't learn something from it. And we took everything we learned and said we need to do better than that. So this is how we came up with the Digital Growth Platform. The Digital Growth Platform puts together all this essence, and basically it starts where Axon Framework stops. So Axon Framework is good for developing Axon-based applications, but it doesn't say anything about the architecture, for instance, about deployment and delivery, and all this that you need to do besides coding this very awesome framework. So let's see how we did it. But first, let's go back one step and think about the problem we have with these monoliths and their integration. So let's go back to this nice pharaoh who would like to build a death chamber into his pyramid. And if you want to build a death chamber into a pyramid, you have to look at the structure of the pyramid. So typically you have a nice shiny tip at the top, which everyone can see. Then that is typically called a presentation layer. Then you have maybe a facade layer, at least that's how it is done in SAP Commerce. Then you have a service layer, and at the bottom you have a database layer. And if you don't have enough complexity into it, you can always add more layers. But there is an issue to it. Each of this layer depends on all the layers below, similar to this pyramid tip and all the stones below. So if you want to replace something in the middle here, you have to tear apart the whole pyramid just to build your death chamber. And this is how the dependencies go. But it gets a bit worse. So if you need to fetch some data from somewhere, then where does this belong? Does it belong here? It has to do with something with HTTP, right? So maybe it goes into the presentation layer. Or does it go into the database layer? I mean, we are getting data from somewhere. But let's be honest, we put a centerpiece of infrastructure into the heart of our software. And you always have to depend on it when you're programming, when you are testing. There's always this dependency that you cannot get rid of, and it creates some coupling. And I would like to thank Allard here, because 2 years ago, I came to this nice Axon conference, and you did this slide with the box, box, circle architecture, and I really love this term. So you have box, 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 and at the bottom you have a circle. So next, let's top this up a bit. He would like to build a pyramid for his wife also, and because they want to be together in their afterlife, they want to build a bridge. So what are the rules for connecting two layered components? Am I only allowed to connect this here or here? Am I only allowed to connect at the same layer, or am I allowed to access all the other layers from the other components too? Well, you cannot know as a developer, and that is what makes things a bit difficult, and now it vanished. Okay, so how to solve this integration challenge? First, let's do an example. We have some touch points, so like a web application, a smartphone app, a support center, or an API. Then we need some kind of gateway, something that allows to go into our world, an inbound adapter. For instance, maybe this client choose GraphQL. Then we use CQRS for decoupling and some domain-driven worker services, which they just control the process flow in them. And we use Axon framework for that. And to the bottom, we have maybe an ERP integration. So something that integrates with the existing infrastructure, an outbound adapter, and maybe the customer has a legacy ERP. And the thing here is they want to migrate to SAP ERP. So it is possible, because the only thing that I mostly need to change is this outbound adapter service. Yeah? I don't need to change much, or optimally nothing in the domain-driven workers. So there's a nice migration path here, and we don't have any vendor lock-in anymore. We can exchange one part of the infrastructure for another without affecting the rest of the architecture. Nice. Okay, let's level this up a bit. So we have the touch points again. We have an inbound adapter that is we call gateway, Sometimes you can also call it backend for the front end or something else. And we have this idea of a process brain that is responsible for coordinating the process flow, which doesn't depend on any technology except for the Axon server. And things are loosely coupled. So we have these neurons that are sending messages to each other to coordinate the flow of the process. And at the bottom, we use CQRS for the infrastructure integration to integrate with what the client already has. Nice. So our integrations now became sustainable. I can change them anytime, and with that I can go with the evolution on the market. Let's level this up a bit. Let's say we start small. We have a web application, a GraphQL gateway, some workers, and an integration with an ERP, and they are in the middle of this integration from custom to ERP to SAP ERP. And now what happens is our customer says, yeah, well, we want to add a shop. We have this wonderful ERP, so let's also add a shop and integrate it. And so we add some worker services for the shop functionality. And here the idea is that for the generic domain and sometimes for the supporting domains, we already have the integrations ready for them. So it isn't redone every time. If you have something generic, then it stays generic. If you have something custom, we will custom build it for our client. So next, we add some app, and the app uses gRPC for whatever reason. Okay, it's just another inbound adapter, no problem. And we maybe because the shop is running so well, I mean, we have all these clients from the web app and the smartphone app. You need a support center, so that uses REST for some kind of reason. And then you need a CRM. You extend your landscape with these workers. That, by the way, we are running mostly in the cloud, of course. So it's designed to be cloud native, API first. Headless, and yeah, and microservice based. So then add a marketplace integration, add some integration with your business partner via Kafka, and everything else you need over time. So what happened here is that we started with something very small, and we were able to scale really fast. So if your business grows, you need to add something, you always have this option of doing that. And with that, I want to come towards the end of my part. So you cannot write a platform without having some basic principles. First, we said process before technology. We have many clients with deciders who said, oh, we need this or that solution. We need an SAP ERP. What do you need for? Well, we don't know. Just let's buy it. And we want to understand the problem first and model the domain before choosing the right technology. And we always have the option to do so at the bottom part. And that is very important. Next, we want to do something sustainable. Typically, our clients come to us, we do a project, and maybe, time has passed by after 3 years, things have changed, the world has changed, and you basically could redo the project. We want to do projects that are running for 5 or 10 or more years, because typically it runs longer than you think. So that brings us to the economies of speed. You need to be fast. You need to be able to adapt to market change. And that is with the return on options. So always having the option to deciding an implementation detail later. And that is thanks to the event sourcing. Next, we have 3 principles that go together. loose coupling, separation of concerns. So there's only a single responsibility for each part in the architecture, and we want to avoid vendor lock-in. Why do we want to do this? Because we want to make this architecture easy to change, to be able to keep up with these economies of speed. And finally, and that is what I really love about this, we want to build a platform that is so much fun. Even if you have a choose your own tools policy, as a developer, you don't want to use anything else because it's so good. So that is why we said we want to be this platform to be developer experience first and customer experience first, because if your developers are happy, they are also fast. That makes customers happy, and the customers will also have a really good experience with the modeling part. And that is why I hand over to Oliver.
That is why you hand over. That's good. So how many seconds? Okay, Tobias, it only left me some seconds, but I will do that in this time. I just want, with this experience we have heard about, I just want to give some additional information about two companies and their projects. Yeah? On the one hand, it's Rose. This is this online pharmacy we heard about. Yeah, we started this project nearly 5 years ago. How counts, depending on how you count. Yeah? And it is a constantly growing ecosystem for healthcare. So, and the thing is, it was a perfect match to focus on things like Mach architecture, domain-driven design, CQRS, Axon, and so on. This was perfectly, and we could prove that. That is important when you are in a situation of a service provider. We can prove this by becoming Axon partner and joining the Mach Alliance. And it goes even further. We had the chance to win the Hidden Champion Award with this, mainly with this input we have here. So in the morning, we heard this question from you, how many products are productive? Yeah, this is one good example for a productive running, for more than 2 years running system on the base of Axon. And the other one is from our home turf in Dortmund. Yeah, a local player, more from the government side, TZNet. There is an event management platform to organize events like this, but more with the idea of a local intercooperation, so that local companies come together and work on project with each other. And the thing is that we could use the situation or the system we have had with this digital gross platform, and this project fully adapted it. So the thing is, we have some kind of starting point, and I will not say end point. That is a local current point we have when we are working with Axon. And both have one additional thing in common. It's for sure possible to start small and scale fast. So to come to a conclusion, the thing is you can't just replace monolithic structure with Mach architecture. Yeah? That is what we learned over the years and projects. You can also make it complicated on the base of microservices. That is the truth, right? So it needs some ecosystem, something that is more than just technology, which combines elements with an end-to-end idea in how to interlock collaboration. That is really important. And to master this, you have to put many things together. Yeah? And therefore, just as a last slide from our side, not to stress up the time here too much, this system, this is more than just technology. It's this ecosystem. It's this possibility to start new projects and to scale from a smaller starting point. And it enables our customers more and more. It is work in progress still, but it enables our customers more and more to some way unlock their business to become this composable business that is so often shown, and to be able to shortly adapt and react on the needed situation you see on your market. Yeah? And when it is shown with this little picture, yeah, we are at the end of our journey, starting with the monolithic hell and ending in the digital gross platform. So we are really interested in your thoughts, so maybe you give us a call or meet us here at the conference or with the app. So thank you very much. Thank you, Tobias.
Fantastic presentation. Thanks. Thanks a lot. There's no questions in the app.
There's no question.
Is it that difficult to you? I'll run towards it. No worries. I'm very curious. Did the Pharaoh eventually get his death chamber, or was that just too
In
impossible?
some projects, he gets it. Yeah, yeah.
And what Lego set would you use to depict the actual more modular evolutionary approach?
Yeah.
And where can I buy it?
We thought it's about so many jokes depending on the structure. But how many money does a pharaoh spend in his project, and how many slaves you have to punish to build your pyramid? There are so many jokes we didn't make today. Huh?
I have one. So the seller of this monolith was a real genius, because they are only selling half a pyramid, so you can sell it twice.
Yeah.
I think we have a question.
Thank you. You in your presentation, you distinguished the CQRS layer on front-end application and other systems. Can you better explain this different approach? Because I didn't understand the details.
Yes.
So it is more of a conceptual separation, I think. So you have this adapter into your Exxon world, and you need a way to get from your Exxon world to the non-Exxon world again for fetching other data, for example, or changing data in the backend systems. Does that answer your question? Yes. Okay.
All right, go have that drink, go have a little coffee, and we'll see each other in,
Thank you.
what is it, 10 minutes?
Thank you.
Thank you.